What are the ice worlds at the edge of our solar system like? Pluto, one of the most controversial objects in the solar system, a tiny, cold celestial body located 40 times farther from the Sun than the Earth, has long remained completely unexplored. This distant and mysterious world was long considered the ninth planet of the solar system, until the International Astronomical Union established new criteria for the concept of planet and deprived the celestial body of the right to be called planet and transferred it to the category of dwarf planets, like a small body of the solar system. But why is Pluto no longer the ninth planet of the solar system? Although Pluto is no longer considered a major planet, it is of great interest to the international astronomical community. Thanks to the knowledge of Pluto's existence, major explorations have led to the discovery of several trans-Neptunian objects comparable in size and mass to Pluto. Named after the Roman god of the underworld, Pluto is now the largest known dwarf planet in the solar system, and the only one in this category located in the Kuiper Belt to have its own complex atmosphere. In addition, on the surface of Pluto, there are a large number of mountain ranges, deep depressions, huge faults in its crust, and ice volcanoes that show interesting geological activity. Pluto is not visible in the night sky to the naked eye. Its largest moon, Charon, is close enough in size to Pluto that it has become common to refer to the two bodies as a double system. Dear traveler, welcome. Today we're off to explore the outer reaches of the solar system to discover the secrets and characteristics of the dwarf planet Pluto. Before flying away for a new adventure, think of liking the video and subscribing to the channel to not miss anything. Thank you, and welcome to the fascinating world of Pluto. Pluto lies in the Kuiper Belt, a region of space beyond the orbit of Neptune. This region is inhabited by thousands of icy and rocky bodies larger than 100 kilometers or 60 miles in diameter, and is a giant reservoir of comets. Pluto is the largest known object in the Kuiper Belt to date. The diameter of the planet is 2,376 kilometers, or about 1,476 miles. This is far less than the diameter of any planet in the solar system, including Mercury, and far less than the diameter of our moon. Pluto is more than 5 times smaller than the Earth. As early as the beginning of the 20th century, astronomers had predicted that a stellar object beyond Neptune, with a mass greater than that of the Earth, was present. When Pluto was discovered, it turned out to be too tiny to have such an influence. Between 1930 and 1978, the estimate of Pluto's mass gradually decreased from 1 Earth mass to 1/10 of the mass of our planet. However, in 1978, the discovery of Charon, Pluto's moon, immediately made it possible to accurately determine the mass of the dwarf planet. It turned out that Pluto is more than 5 times lighter than our moon and is 5/100ths the mass of the Earth. The volume of the dwarf planet is about 152 times smaller than the volume of our planet. This means that up to 152 Plutos could fit inside the Earth. If we divide the mass of a planet by its volume, we get the average density. The average density can indicate the composition of the planet. For example, the density of Mercury and the Earth is greater than 5 grams per cubic centimeter. This suggests that the composition of these planets is dominated by metals and rocks. The density of Jupiter and Saturn is only about 1 gram per cubic centimeter because they are gaseous planets. The average density of Pluto is 1.88 grams per cubic centimeter. This is an intermediate value between gas planets like Jupiter and rocky planets like Earth. Various ices play an important role in the composition of Pluto. Chemically, Pluto seems to be composed of 70% basaltic rocks and 30% water. Pluto moves around the Sun in an orbit that is different from the orbits of the major planets in the solar system. All the major planets orbit the Sun on approximately the same plane, which is the ecliptic plane, and Pluto's orbit is tilted toward it by 17 degrees. In addition, Pluto's orbit is elongated, more like an oval than a circle. Because of the elongation of the very elliptical orbit, Pluto moves away from the Sun up to 49 astronomical units, then approaches at a distance of 30 AU. It should be remembered that an astronomical unit is the average distance from the Earth to the Sun, about 150 million kilometers or 93 million miles. Therefore, the dwarf planet sometimes comes closer to the Sun than Neptune. This event represents only 20 years in Pluto's 248-year period of revolution. The last time Pluto was closer to the Sun than Neptune was between 1979 and 1999. At that time, Pluto was officially considered the 8th planet from the Sun, and Neptune the 9th. The length of a day on Pluto differs from ours. A Plutonian day lasts about 153 Earth hours, or more than 6 Earth days. It should be noted that the planet moves very slowly in its orbit. Pluto's average orbital speed is only 4.74 kilometers per second, or 3 miles per second, which is about 6 times slower than the orbital speed of the Earth. Pluto reaches its maximum speed at perihelion at 6 kilometers per second, or 3.7 miles per second, and the minimum at aphelion is 3.7 kilometers, or 2.3 miles per second. Because of Pluto's small mass, the free-fall acceleration here is only 0.6 meters per second, whereas on Earth, it is about 9.8 miles per second. The space probe New Horizons, during a flyby of Pluto, tried to detect a magnetic field near the planet, but without obtaining any result. The small size of the dwarf planet and the slow rotation around its own axis indicate that such a field may not exist. The discovery of Pluto did not happen by chance. Astronomers have suspected the existence of an unknown planet beyond the orbit of Neptune since the second half of the 19th century. By studying the orbits of Uranus and Neptune, astronomers have found that the planets are a bit out of alignment. They have clearly deviated from the theoretically predicted positions in the sky. To explain this phenomenon, scientists propose the hypothesis that the gas giants are attracted by an unknown planet beyond the orbit of Neptune. It should be noted that the existence of Neptune was mathematically predicted from the same deviations of the orbit of Uranus, then brilliantly confirmed in practice. The new planet, Neptune, has perfectly explained almost all the discrepancies in the motion of Uranus, but some deviations still remain. Deviations were also observed in the motion of Neptune itself, which astronomers could not explain by the attraction of Uranus, Jupiter, and other planets of the solar system. So there was an unknown planet. A huge contribution to this discovery was made by Percival Lowell, an American businessman and amateur astronomer. Between 1905 and 1915, he found areas of the sky where an unknown planet could be found. In 1906, the staff of the Lowell Observatory conducted its first search, but without result. Pluto was discovered by astronomer Clyde Tombaugh in 1930 at an observatory built by Percival Lowell. Tombaugh deliberately searched for the planet for nearly a year, looking at photographs of sections of the night sky every day. The search method was simple, but very energy-intensive. The astronomers took a picture of one of the areas of the sky where the planet could conceivably be found, developed a photographic plate, and set it aside. 2 days later, the same area was photographed again, and 2 days later, for the third time. Next, the photographic plates were placed in a special tool, a blinking comparator. This tool made it possible to view images under the microscope, and more importantly, to quickly switch from one photographic plate to another. If the photographs had concealed the sought-after planet, then within 2 days, the latter would have moved on the background of the stars. By rapidly changing photographic plates, it could then be detected as a jumping star. Tombaugh examined these images daily, trying to find, among the thousands of faint stars, one that would not stay still but would move. Each day, he found objects that were moving, but these were ordinary asteroids and, in some cases, simple photographic emulsion defects. The young astronomer continued to search further. This tedious and to some boring activity continued throughout the summer and fall of 1929. Parts of the sky were photographed in the constellations of Aquarius, Pisces, and Aries. With the onset of winter, the shift in the constellation of Taurus began, followed by Gemini. There were many stars in the pictures, because the Milky Way crosses these constellations. Finally, on February 18, 1930, the astronomer discovered a distant, dark star moving so slowly against a background of stars that it should have been beyond the orbit of Neptune. The next night, Tombaugh received the fourth plate to verify the presence of the object he was looking for, and the object was found where it should be. The observatory staff still had doubts and did not believe in the existence of this new planet at all. It took almost a month to carry out all sorts of checks. Finally, on March 12, 1930, a telegram was sent to the administrator of the Lowell Observatory so that the message could be forwarded to Harvard, and then it was distributed to many astronomers and observatories around the world. The planet Pluto was named after the Roman mythological god Pluto, god of the underworld. The name was suggested by an 11-year-old English girl named Venetia Burney. The name turned out to be extremely apt because of Pluto's distance from the Sun, located on the edge of darkness. For a long time, astronomers could not say anything precise about the nature of Pluto because of its distance. They could only estimate the size and mass of the new planet, but these estimates were very unreliable. There was no data on the composition of Pluto. Only since the late 1970s and the 20th century, after the discovery of its moon Charon, have observers been able to shed light on the structure of this world. Studying Pluto from Earth is extremely difficult because of its distance and small size. Even the Hubble Space Telescope cannot see its surface in detail. The only source of information about Pluto's surface is NASA's New Horizons mission. It is the first and only probe to study closely the dwarf planet Pluto and its moons. This probe carried part of the ashes of the discoverer of Pluto, Clyde Tombaugh. In January 2006, NASA sent the interplanetary space probe New Horizons to explore Pluto when it was still the 9th planet in the solar system. In July 2015, after 9.5 years and 5 billion kilometers of travel, the space probe New Horizons reached Pluto, already become a dwarf planet, and for the first time in human history, a close-up photograph of Pluto was taken. On July 14, 2015, the New Horizons probe flew at a distance of about 12,500 kilometers, or 7,800 miles from the surface of Pluto, receiving numerous photographs and scientific data about the surface and atmosphere of the dwarf planet. Because the travel time of the radio signal from the station to Earth was more than 4.5 hours, direct control of New Horizons from Earth was impossible. All operations and observations were performed automatically according to a predetermined program. During the flyby, as well as before and after, numerous observations of Pluto, Charon, and the small moons were made. The probe made a total of more than 400 observations during only 9 days, during which it collected about 50 gigabytes of scientific data. The transfer to Earth of all the collected information continued until October 25, 2016. After the flyby of Pluto, and in the continuation of its journey to explore the edges of our solar system, the space probe New Horizons took photographs of the trans-Neptunian objects of the Kuiper Belt, the most distant images ever taken. Since 2022, New Horizons has moved more than 50 astronomical units from the Sun, and the station continues to conduct space exploration and astrophysical observations. It is assumed that New Horizons will remain operational until at least 2035, and will be able to conduct scientific research at a distance of more than 90 astronomical units from the Sun. On August 24, 2006, Pluto lost its status as a planet of the solar system by decision of the 26th General Assembly of the International Astronomical Union, held from August 14th to 25th, 2006 in Prague, Czech Republic. Pluto has been demoted to a dwarf planet. The Global Forum for Physics and Astronomy has established a new classification of celestial objects in the solar system into major planets, dwarf planets, asteroids, and comets. In fact, during the 40 years following its discovery, the nature of Pluto was not clear. What bothered astronomers was the orbit of the new planet. All the planets in the solar system revolve around the Sun, in more or less the same plane. But Pluto's orbit is highly inclined, just like the orbits of comets and asteroids. Moreover, Pluto's orbit is elongated, so much so that it looks more like an oval than a circle. As a result, Pluto is sometimes closer to the Sun than Neptune. This led to questions about Pluto's status. Why, in fact, is it considered a planet? Perhaps it is a large asteroid, like Ceres or Vesta. Astronomer James Walter Christie, who discovered Charon, Pluto's moon, in 1978, added fuel to the fire. The presence of a moon immediately made it possible to calculate the mass of the planet. It turned out to be incredibly small. From then on, doubts about Pluto grew. Perhaps it was only a large asteroid. But why is Ceres, the largest asteroid in our solar system, located between Mars and Jupiter, not considered a planet in its own right? You'll be surprised, but in the 19th century, Ceres was considered one of the planets of the solar system, and was even listed in old astronomy textbooks. Then, At about the same distance from the Sun, other celestial bodies began to be discovered. In the mid-19th century, it turned out that there were dozens of Ceres-like objects between Mars and Jupiter, and by the 20th century, astronomers found that there were tens of thousands. In fact, Ceres turned out to be simply the largest of these many objects. Therefore, astronomers reclassified these bodies, including Ceres, as dwarf planets or asteroids, and the very accumulation of such objects became known as the asteroid belt. But is Pluto alone in its orbit or not? Starting in 1992, many small objects began to be discovered beyond the orbit of Neptune. In this region of space, a cluster of small icy bodies, called short-period comets, has long been suspected. Astronomers have even given the region a name, the Kuiper Belt. Thus, some of these objects were located well beyond Pluto, some closer, and some moved around the Sun on orbits almost coinciding with the orbit of Pluto, just as in the case of Ceres. Another oddity was discovered after studying the composition of Pluto. From all indications, including density, color, and spectral characteristics, it was mostly ordinary ice. So, from the point of view of its structure, it looked much more like a giant comet than a planet. In addition, objects of similar size to Pluto have begun to be discovered in the Kuiper Belt. Makemake, Sedna, and Haumea were smaller than Pluto, but Eris was comparable in size or even slightly larger. Should we also call it a planet, the 10th planet? At first, this was the intention of the astronomers, but then they changed their minds because it turned out that there could be a dozen or even 100 comparable objects in the Kuiper Belt. It was then time to change the criteria for classifying the planets of the solar system. In 2006, at the International Astronomical Union Congress in Prague, astronomers adopted a new definition of the term planet. Now, we call a celestial body a planet, 1, if it orbits the Sun and is not the moon of another object, 2, if the body is massive enough to take the form of a hydrostatic equilibrium, close to spherical, under the influence of its gravitational forces, 3, if it is capable of clearing other bodies from the vicinity of its orbit, i.e., it must be a gravitational dominant, and there must be no other bodies of comparable size nearby, except its own moons. According to the new definition, Pluto, like Ceres, meets the first two requirements, but it fails the third criterion. Scientists have pointed out that Pluto cannot clear the space around its orbit. In fact, there are too many other objects around it, and this is the main reason for excluding it from being a major planet in the solar system. What should we call it then? An asteroid? But asteroids in their mass are just huge blocks of stone and metal, while Pluto is large, spherical, and icy. Or a comet? But comets are small and irregularly shaped. Pluto is a giant compared to them. Astronomers have decided to introduce a new term, dwarf planets. While these planets are spherical and large enough to stand out from the mass of asteroids, they do not have the characteristics of full-fledged planets like Earth, Jupiter, or Neptune. Not only Pluto has received such a label, but also Ceres, the largest object in the asteroid belt, Makemake, Eris, and Haumea. Thus, to date, 8 large planets and 5 dwarf planets are known in the solar system. The origin of Pluto and its characteristics have long been a mystery. In 1936, the English astronomer Raymond Littleton hypothesized that it was an escaped moon of Neptune that was propelled out of orbit by Neptune's largest moon, Triton. This hypothesis was strongly criticized because Pluto never approaches Neptune. Starting in 1992, astronomers began to discover more and more small icy objects beyond Neptune's orbit, similar to Pluto, not only in orbit, but also in size and composition. This part of the outer solar system was named after Gerard Kuiper, one of the astronomers who, reflecting on the nature of trans-Neptunian objects, suggested that this region was the source of short-period comets. As of July 2015, Pluto is considered the largest object in the Kuiper Belt. Pluto has all the characteristics of other Kuiper Belt objects, such as comets. The solar wind blows icy dust particles to Pluto's surface. If Pluto were as close to the Sun as the Earth, it would develop a cometary tail. Although Pluto is considered the largest object in the belt discovered to date, Neptune's moon Triton, which is slightly larger than Pluto, shares many geological, atmospheric, compositional, and other properties with it. Triton is thought to be initially a belt object captured by Neptune. Eris, which is close in size to Pluto, is not considered to be an object from the Kuiper Belt. It was established in July 2015 that Pluto is larger than Eris. Most likely, Eris belongs to objects in a region known as the scattered disk. A considerable number of Kuiper Belt objects, such as Pluto, have a 3-to-2 orbital resonance with Neptune, meaning that they make 2 orbits around the Sun, while Neptune makes 3. Such objects are called plutinos. Each planet in the solar system has its own color. Venus is dazzling white because of dense clouds. The rusty sands of Mars make the planet red. The Earth is blue because of the oceans. What color is the planet Pluto, and why? In the 1930s, almost immediately after the discovery of Pluto, astronomers discovered that its color was yellowish. Although the planet looked like a very faint star in a telescope, the color could be found if its brightness was measured with color filters. Later, it was discovered that Pluto was very similar to Triton, the largest moon of Neptune. Indeed, they have similar sizes and weights, and frozen nitrogen is present on their surface. In 1989, NASA's Voyager 2 probe flew over Neptune and photographed Triton at close range. It turned out that in some places Triton is brick red. This hue would be explained by the action of solar radiation on methane ice. Astronomers expected something similar on Pluto. However, even the Hubble telescope could not scrutinize the dwarf planet in detail. Everything changed in 2015 when the probe New Horizons flew over Pluto. Detailed images allowed to determine the overall color of the dwarf planet as the sum of white, brown, and yellow colors. The dwarf planet is depicted in natural colors, which are the result of precise calibration of data collected by the probe's visible, multispectral color camera. As a result, the former 9th planet of the solar system is rich and diverse in color. It has snow-white ice plains and dark brown mountainous regions. Part of the surface is painted beige, and the areas near the North Pole reveal a yellow hue. In 2015, when NASA's New Horizons probe flew by Pluto, a relatively complete image of its surface was revealed. In the photographs taken by the probe, Pluto's surface looks extremely interesting. There is a great variety of landscapes. entire mountain ranges with peaks reaching 6 kilometers in altitude, with the Tenzi Mountains, craters, and ice plains. Most of the surface is covered with ice. It is composed of methane and nitrogen. Methane ice gives the surface of the planet a characteristic reddish hue. Interestingly, neither the methane ice nor the nitrogen ice is tough enough to form mountains a kilometer or a mile high. Astronomers assume that the mountains are composed of ordinary water ice. Most of Pluto's surface structures discovered have been given preliminary names. In 2017, the International Astronomical Union assigned official names to 14 more of Pluto's landform structures discovered by the New Horizons station. These are mostly furrows, mountain valleys, craters, and lakes on the surface of our dwarf planet. The most remarkable geological structure found on Pluto is the Sputnik Plain. It is a depression over 1,000 kilometers or more than 620 miles, probably a heavily destroyed impact crater. It is filled with frozen gases, mainly nitrogen, and crossed by many furrows that divide it into cells of several tens of kilometers. The work of a team of scientists based on observations from New Horizons shows that a significant part of Pluto's landscape was formed as a result of cryovolcanism. This process is similar to the volcanism we are familiar with, but instead of lava, a liquid mixture of various compounds, including ammonia and methane, is poured onto the surface, which turns into ice. For example, southwest of the famous Sputnik Plain, these ice mountains rise 7 kilometers or 4 miles high. This is one of the regions with very few impact craters, dominated by huge hills with rugged slopes. Features like this exist nowhere else in the solar system. Such landscape features suggest that Pluto's internal structure and evolution have allowed it to better retain internal heat, or that there was originally more of it than previously thought. The areas around the Sputnik Plain have attracted the most attention from researchers. In particular, ice volcanoes, which despite their similar external structure to ordinary volcanoes, differ given the characteristics of cryovolcanoes, specific gravity, geochemistry, and temperature on the surface of Pluto. All the territory of this region is formed by the products of the eruption of cryovolcanoes, which makes it unique in the solar system. Furthermore, the latest eruptions of cryovolcanoes may have occurred relatively recently, since only one impact crater has been discovered. This suggests that the region is quite young by planetary standards. And furthermore, there are fewer craters in this region than one would expect. The presence of active ice volcanoes, at least in the recent past, means that Pluto has remained geologically active much later than scientists previously thought. For a body as small as Pluto, this is unusual, and scientists cannot yet explain the persistence of heat in Pluto's depths for such a long period of time, enough heat to cause active cryovolcanism. Traces of cryovolcanoes have also been found on other objects in the solar system, on the dwarf planet Ceres, on Saturn's moon Titan, on Jupiter's moon Europa, and on Pluto's moon Charon. But cryovolcanism is not so easy to determine because such a phenomenon does not exist on Earth and therefore cannot be explored with great precision. Moreover, each object has its own characteristics in the course of this type of process. It is estimated that 30 to 50% of Pluto's mass is in the form of ice. The mantle is made of water ice, while the crust and surface of the dwarf planet are formed by stranger ices of nitrogen, carbon monoxide, and methane. The remaining 50 to 70% of the dwarf planet's mass is concentrated in its core and is represented by stony rocks. The diameter of the core is about 1,700 kilometers, or 1,050 miles. It is possible that beneath Pluto's icy surface is an entire ocean of liquid water, heated by the decay of radioactive substances in the dwarf planet's bowels. Scientists are getting more and more evidence that Pluto hides an ocean of liquid water under the ice crust. Models created by researchers at Brown University in the United States not only support this hypothesis, but also complement it. According to the scientists, the ocean on Pluto could be more than 100 kilometers or 60 miles deep. The discovery, published in the journal Geophysical Research Letters, comes from observations in the Sputnik Plains region of a huge heart-shaped crater that has become one of the symbols of the dwarf planet. It turns out that the Sputnik Plain is located directly on the tidal axis, connecting Pluto to its largest moon, Charon. As other researchers note, this curious position means that the Sputnik Plain is an unusually heavy part of the planet's crust. There is a theory that a huge asteroid that collided with Pluto near the North Pole is responsible for creating this crater, but over time, the planet's core became too heavy, causing Pluto's axis to shift. The impact crater is actually just a hole in the ground, but in the case of Pluto, this hole led to an increase in the mass of this part of the planet, which led to the question of what caused this. One hypothesis holds that after the crater formed, the Earth would have naturally compensated for the gap by drawing water from Pluto's deep interior. Other studies have shown that there may still be plenty of liquid water near the planet's hot core. Because water is denser than the ice that makes up most of Pluto's crust, it may well have made the Sputnik Plain heavier than its surroundings. But exactly how much water does it take to make Pluto's core heavy enough? To answer this question, researchers performed a series of tests simulating a Pluto impact with an asteroid. It turns out that to recreate the image of the processes that took place on the planet and led to its modern appearance, it would take an ocean more than 100 kilometers or 60 miles deep and a salinity level of about 30%. In fact, salinity increases the density of the water, which leads to an even greater increase in mass. 30% salinity is the approximate level of water in the Dead Sea. It should be noted that the deepest point of the ocean floor on Earth is only 10 kilometers or 6 miles deep. So you can try to estimate the depth of this ocean under the ice. Pluto's atmosphere was discovered in 1988 during the occultation of a star by the dwarf planet. The principle of this phenomenon is simple. By moving from its orbit, Pluto has camouflaged a star far from us for a while. It turned out that during the event, the brightness of the star did not drop suddenly, but gradually. The cause was the layer of the atmosphere, which partially absorbed the light of the star. In 2015, the probe New Horizons flew over the dwarf planet. Its data allowed scientists to study in detail the composition and structure of Pluto's atmosphere. The main gas in Pluto's atmosphere is molecular nitrogen, making up 99% of its volume. The air envelope of a dwarf planet is similar to that of the Earth or Titan, Saturn's largest moon. the atmosphere also contains small amounts of methane and carbon monoxide. In addition, complex organic compounds are present in trace amounts. Hydrocyanic acid, ethane, acetylene, and other compounds. The atmosphere of Pluto is very thin. The pressure at the surface of the dwarf planet is about 1 Pascal, which is 100,000 times less than that of our planet. Although Pluto's atmosphere is extremely rarefied, the New Horizons probe found traces of it more than 1,000 kilometers or 600 miles from the planet's surface. But this is not the limit. Astronomers are sure that it extends over distances 7 times greater than the radius of Pluto itself. To explain the volume of space occupied by Pluto's atmosphere, planetary scientists give the following example. The Earth's atmosphere has a height scale, that is a thickness when the atmosphere is compressed to a uniform pressure and density, of about 10 kilometers or 6 miles. At the same time, the radius of the Earth is 6,371 kilometers, or about 4,000 miles. Therefore, the thickness of the homogeneous Earth's atmosphere is very small and is only 0.17% of the radius of our planet. In addition, the outer layers of the Earth's atmosphere can be traced at altitudes of about 600 kilometers or 370 miles, which is 1/10 of the Earth's radius. The difference for Pluto is that the height scale of its atmosphere is about 50 kilometers or 30 miles, or nearly 5% of its radius, which is 1,188 kilometers or 745 miles. Considering the outermost layers, it may turn out that the volume of space occupied by Pluto's atmosphere is over 350 times the volume of Pluto itself. It seems strange that a celestial body as small as Pluto could have an atmosphere. At first glance, it is all the more surprising, since neither the Moon nor even the planet Mercury have much of an atmosphere, even though they are much more massive and larger than Pluto. However, there is an explanation for this. Our Moon and Mercury are close to the Sun. Therefore, the molecules of all the gases on their surface are so heated that they overcome the attractive force of these bodies and escape into space. Pluto is far away, in the cold and darkness. The energy of the air molecules is not enough, so they float above the surface of the dwarf planet. Moreover, one of the most surprising discoveries is that Pluto is surrounded on all sides by a bluish haze. It is beautifully visible in photographs that the NASA probe took after the flyby of Pluto, especially when the dwarf planet was illuminated from behind by the Sun. The haze extends up to 300 kilometers or 185 miles above Pluto's surface. The blue tint is given to it by complex organic molecules. These are the tholins. Although these organic substances floating in the atmosphere are themselves reddish, they disperse the blue color, just like oxygen and nitrogen in Earth's atmosphere. Then, the tholins settle on the surface of Pluto, coloring it an orange-brown color. A mysterious feature of Pluto's atmosphere is revealed by comparing it to that of Triton, the largest moon of Neptune. In fact, the properties of Pluto are very similar to those of Triton. The composition and atmosphere of these celestial bodies are similar. However, Pluto's atmosphere is much thicker, even though Triton is more massive. Since Pluto is currently moving away from the Sun, astronomers assumed that most of the nitrogen in Pluto's atmosphere had already escaped into space or frozen. Nevertheless, in 2015, the New Horizons mission discovered that the dwarf planet retained a surprisingly dense haze. Where did it come from? Scientists have suggested that something is powering it. For example, Triton's atmosphere is constantly fed by geysers and cryovolcanoes on its surface. Perhaps Pluto has its own geysers? This is indirectly confirmed by areas of a very young surface on which craters are absent. They could therefore appear as a result of tectonic activity. Thanks to methane, Pluto experiences a greenhouse effect. The temperature fluctuations seem rather strange for an Earth inhabitant. The surface of Pluto is quite cold, with temperatures often below -230 degrees Celsius or -382 degrees Fahrenheit. But if you go higher up, for example in the mountains, the temperature will be a bit higher. Unlike Earth, where the poles are the coldest places, the poles of Pluto are the warmest regions. In a recent study, astronomers from the University of Tasmania in Australia came to the conclusion that by 2030, the atmosphere of the dwarf planet could completely freeze and disappear. The astronomers studied seasonal changes in Pluto's surface pressure, depending on the amount of sunlight it receives as it orbits the Sun. They found that when Pluto is at aphelion, the point in its orbit where its distance from the Sun is greatest, nitrogen freezes in its atmosphere. Pluto is the only object in the solar system that has a pronounced elliptical orbit. As a result, the distance between the dwarf planet and the Sun is constantly changing, which significantly affects the seasons. Today, scientists have discovered that some seasons on Pluto are colder than others, so much so that the atmosphere, which consists mainly of nitrogen, literally freezes and falls off the planet's surface, leaving a complete vacuum. Also, the force of gravity and the length of the day negatively affect the atmosphere of the planet, changing it with devastating force. The researchers note that over the past 30 years, Pluto's atmospheric pressure has increased by 3 times. The scientists' models show that most of the atmosphere will condense outward until little remains. The researchers' simulations indicate that by 2030, the planet's entire atmosphere will freeze and disappear completely. If this really happens, then Pluto will look different. The frozen nitrogen in the atmosphere would reflect more sunlight, so the dwarf planet would appear brighter in the sky. But its surface will also change. The brick-red colors observed by the New Horizons mission will disappear under the nitrogen frost, until the next approach of the Sun. Pluto's atmosphere is thought to have been formed by the melting of surface ice. When the planet approaches the Sun, it heats up a bit. This heat is sufficient to partially evaporate the ice on its surface. This creates an atmosphere. As it moves away from the Sun, the ice stops evaporating and replenishes the atmosphere with gas. As a result, most of Pluto's atmosphere escapes into space and the rest freezes. Practically, the air cover disappears. However, as long as Pluto has an atmosphere, strong winds can apparently blow across the planet. In fact, in 2016, scientists announced that they could detect clouds. Using data from New Horizons, researchers saw 7 bright features near the terminator, which represents the fictitious dividing line between the bright and dark areas of the dwarf planet. The boundary between daylight and darkness is where clouds typically form. All the observed objects are located at a low height and about the same size. If they are indeed clouds, they are most likely made of acetylene, ethane, and hydrogen cyanide. There is also a hypothesis that in the distant past, Pluto's atmosphere was much denser. Thus, New Horizons photographed a frozen lake in the Tombaugh region, located on the surface of Pluto, next to which it seems ancient channels exist. If this is true, then Pluto may have once supported the existence of liquids on its surface. In the past, Pluto's atmosphere was 40 times thicker than on Mars. Pluto has 5 moons discovered: Charon, Hydra, Styx, Nix, and Kerberos. The closest and at the same time the largest is Charon. The farthest is Hydra, which is also the second largest moon. Like the moon in relation to the Earth, Charon always looks at Pluto with one of its faces. It seems to hang in the same place. This effect is due to the fact that Charon moves at the same speed as Pluto rotates around its axis. Since its discovery in 1930 and until 1978, Pluto was a mysterious planet for astronomers. Scientists knew neither its size nor its mass nor its composition. All the characteristics of the dwarf planet, except for its orbit, were covered with obscurity. Thus, in 1978, at the U.S. Naval Observatory, the astronomer James Walter Christie discovered a moon of Pluto. It was an unexpected discovery. The moon was so close to the planet that in photographs they almost merged into a single object. It immediately became clear that this was a relatively very large moon. Its size is about half the size of a dwarf planet. The moon was named after the mythological Charon, the transporter of the souls of the deceased to the realm of Hades across the river Styx. The discovery of Charon provided the key to understanding Pluto. Indeed, if the planet has a moon, then using Newton's laws, it was possible to immediately calculate the masses of both bodies. If Pluto were to be as massive as the Earth, then obviously it must be very dense and composed of metals and rocks. If Pluto's mass was small, then its nature was more like that of the moons of giant planets. Pluto turned out to be not only light, but incredibly light, about 5 times less massive than the moon. However, it was calculated that the moon Charon was only 8.6 times less massive than the planet. In addition, Charon is very close to Pluto, at a distance of about 19,600 kilometers, or 12,200 miles. This is almost 19 times less than the distance from the Earth to the Moon. Charon completes 1 revolution around Pluto in 6.4 Earth days. The duration of a day on Pluto is exactly the same. This means that Charon is always above the same spot on Pluto's surface. Since Charon and Pluto are very similar in size, their orbits are different from those of most planets and their moons. For example, the Moon may be said to revolve around the Earth, although this is not true. Both the Moon and the Earth revolve around a common center of mass. But this center is located inside the Earth, below its surface, so such a simplification of reasoning is justifiable. Nevertheless, the center of mass of the Pluto-Charon system is outside Pluto. The 2 bodies revolve around a point in space between them, much like the orbits of binary star systems. This is a unique property for large bodies in the solar system. The Pluto-Charon system is often considered a double planet. The reason is not only because the planet and its moon are unusually close to each other. Charon is not only unusually massive for a satellite, but only about twice as small as Pluto in size. In fact, Charon's diameter is about 1,200 kilometers or 745 miles, while the dwarf planet's diameter is 2,376 kilometers or 1,475 miles. Astronomers believe that the two celestial bodies probably formed at the same time when two similar-sized objects collided. Unlike most planets and moons, the Pluto-Charon system is tilted sideways from the orbital plane. In addition, Pluto rotates around its axis in the opposite direction compared to most planets. All this may indicate the rapid birth of the system. This is explained by the fact that Pluto and Charon have a very different appearance, have a different structure. So, the proto-Pluto and the proto-Charon were completely different worlds. Images from the New Horizons probe have shown that Charon's surface is dotted with craters, rifts, and grooves. This is in contrast to the appearance of Pluto. Apparently, Charon's surface is much older than the surface of the dwarf planet. Charon's color is whitish-gray, while Pluto's color is a mixture of white and yellow-brown areas. Obviously, the surface of Charon is composed of water ice. It is worth remembering that at a temperature of minus 220 degrees Celsius, or minus 364 degrees Fahrenheit, which is the usual temperature on Charon, the ice becomes solid, like metal. In addition, New Horizons has discovered an amazing formation at the North Pole of Charon. It is a large reddish-brown spot. This reddish hue is similar to the color of the surface of Pluto. Where does this spot come from? Astronomers believe it comes from Pluto's frozen atmosphere, which has settled and frozen to the surface of its moon. Pluto is too small to firmly hold on to an atmosphere, so gases are constantly leaving it, escaping into space. Without the ice on Pluto's surface, which feeds the atmosphere, it would have evaporated long ago. In close orbit, Charon captures some of the nitrogen and methane, which then freezes and settles on its surface. Under the influence of solar and cosmic ultraviolet rays, chemical reactions occur in this layer, by which complex organic compounds are created. These are the tholins, explaining then the reddish color. Further studies of Pluto have allowed astronomers to discover 4 more moons. All were discovered between 2005 and 2012. 2 more moons, Nix and Hydra, were discovered in 2005 using the Hubble Space Telescope. These moons are 2 and 3 times further away from Pluto than Charon. Nix is 42 kilometers or 26 miles long, and 36 kilometers or 22 miles wide, while Hydra is 55 kilometers or 35 miles long and 40 kilometers or 25 miles wide. A 4th moon, Kerberos, was discovered in 2011, also in Hubble images. It is a very small moon, measuring 12 by 6 kilometers or 7 by 4 miles. The 5th moon, Styx, was discovered in July 2012. Its maximum length is about 16 kilometers or 10 miles. These moons are much smaller in size than Charon and have a co-directional motion with Pluto. All the moons except Charon are not spherical and reflect more light. The brightness of Hydra, Styx, Nix, and Kerberos is probably due to the ice on their surface. Because of the remoteness of Pluto, astronomers have tried to predict the presence of rings by indirect signs. In 1994, scientists published calculations in a study. In their opinion, Pluto's rings, if they exist, should be located at a distance of 1,200 to 10,900 kilometers, or 745 to 6,800 miles from the center of the planet, and the rings of its satellite Charon, if they exist, at a distance of 600 to 4,200 kilometers, or 370 to 2,600 miles from Charon's center. Hypotheses about the existence of rings were put forward in 2006 by a group of American scientists. They speculated that the sources of the ring substance could be Pluto's moons, Hydra and Nix, as well as Kerberos and Styx discovered later. In August 2011, a group of Brazilian astronomers presented their calculations. According to them, Pluto's moons are constantly bombarded with micrometeorites, as a result of which an extremely faint dust ring could form around Pluto, 16,000 kilometers or 10,000 miles wide, and with a particle diameter of 1 to 10 microns. Due to the solar wind, half of the particles are expected to settle back onto the moons within a year. Nevertheless, in 2015, the data provided by the mission of New Horizons showed that no ring was finally found near Pluto, although the approach of the probe to the planet gave the best opportunity to see if it existed. Thus, the absence of rings was confirmed. The dwarf planet Pluto is in many ways lucky to exist in its orbit, which is quite unusual. A new study shows that in order to stabilize in this orbit for many years, factors favorable to a dwarf planet should have developed. The former 9th planet of the solar system, now considered a dwarf planet, has a very elongated orbit with an inclination of 17 degrees to the ecliptic. Pluto's orbital period is 248 years, and for about 20 of those years it lies within the orbit of Neptune. The fact that their orbits intersect, but the planets do not collide, has interested scientists. It turned out that two properties of Pluto's orbit contribute to this situation: azimuthal and latitudinal librations. Librations are oscillatory perturbations related to the rotation rate of a planet, resulting from a gravitational coupling with orbital partners, here Neptune. They are called azimuthal because these anomalies describe the shape of a given orbit. The latitudinal libration ensures that when Pluto reaches its closest point to Neptune, or the other giant planets, it is always well above them and the plane of the solar system. The latitudinal libration ensures that Pluto is far from the ecliptic plane when the dwarf planet is at its closest point to Neptune. These two factors allow Pluto to avoid the risk of collision with Neptune. The planetary scientists decided to find out why Pluto had such conditions. Through computer simulations, they determined that Neptune, as expected, has the most influence on Pluto's azimuthal libration because they are in a 3-to-2 orbital resonance. Thus, for every 3 revolutions of Neptune around the Sun, Pluto makes exactly 2. But models have shown that Neptune has virtually no effect on Pluto's latitudinal libration. The authors of the study worked the model taking into account the gravity of Uranus and found that it introduces even more instability in the orbit of Pluto, destroying the effect of azimuthal and latitudinal librations. If Pluto's orbit depended solely on the influence of its 2 neighboring planets, it would become unstable after only tens or hundreds of millions of years, causing Pluto to collide with Neptune or be ejected from the solar system. In their simulations, the researchers ran the modeled representation for the next 5 billion years. They included in the project the influence of Saturn with Jupiter. Then the picture took shape. Even though they are farther away from Pluto than Neptune and Uranus, the gravitational influence of Saturn and Jupiter is very strong. Jupiter alone provides enough impact to keep Pluto's orbit stable for the duration of the simulation. The authors were also struck by the small margin of Pluto's orbital stability zone. If there were slight deviations, the gravity of the giant planets would eject it from the solar system or lead to a collision with Neptune. This study is also important from the point of view of understanding the orbital mechanics of trans-Neptunian objects, which often also have highly inclined and elongated orbits. A curious conclusion: Jupiter has mainly a stabilizing effect on the orbit of Pluto, and Uranus has a destabilizing effect. But above all, Pluto's orbit is really close to the zone of strong chaos. The discovered interaction is also important to evaluate the migration of planets in the solar system and other systems, and the influence of giant planets on these processes. For example, one can try to determine from the deviations and observed parameters of the orbits signs of the previous presence of planets that were ejected from the solar system in the past. The result of the new work will greatly influence the study of the evolution of the motion of bodies in our solar system. Further study of the migration of giant planets, with numerical restrictions on the dynamics of the development of the solar system, will allow us to finally understand how Pluto and other bodies ended up in their orbits. Current theory of stellar evolution suggests an increase in the brightness of our Sun. Over the next billion years, it will become 11% brighter. The habitable zone of the solar system will then be moved beyond the limits of the current Earth orbit, reaching Mars, Jupiter, and then Saturn. After 5 billion years, the core of the Sun will heat up so much that it will start the process of burning hydrogen in the envelope that surrounds it. This will lead to a strong expansion of the external radiation of the Sun, and it will become a red giant. It is possible that then, on the objects of the Kuiper Belt and on Pluto, there will be acceptable conditions for the development of life. Pluto will be able to maintain these conditions for tens of millions of years until the Sun becomes a white dwarf. Perhaps by that time, alien life will have colonized both Pluto and many Kuiper Belt objects, as temperature conditions will have changed, as well as the composition of the atmosphere due to melting ice. Pluto will be able to maintain such conditions for tens of millions of years. Who knows, maybe humans of the future will have established a home in this new oasis of life.